Hey everybody, this is Brad Dyke. How you doing? I wanted to talk to something about AI. My corporate CEOs and our technology officers have asked the question, the grand question that's I've been expecting for about 2 years now. How can we use AI in an industry? Now it doesn't matter who the CTO is or the CEO or someone like and so on, and that's an example. But what do you do when you look at AI and you say, I have to start using this? That's the real question. Now, back here on the Proxmox platform on the bottom side, I have a box that has AI on it. It's called Private AI. Now, it's a communication AI. It is not such as creative AI, which would be used for something like DevOps or operations, IT operations. That works more with code, not necessarily with English language, but with code. Give me a second. So, with that being the case, AI is becoming something unique in its capacity. But there are some penalties that exist with AI. For AI to be responsive, in other words, you type in a question, what is the value of a Pegasus? Now, Pegasus is a very rare word. You're going to have real difficulty trying to source that one out. You would find out within a second or two, if you have GPUs, or 15 or 20 seconds, a response will pop up and give you an answer. Now that's language-based AI. Now, you can expand linguistics into code and to other types of communication. But the key word is communication. Script files, DevOps components, Puppet, Ansible, things like that, they have requirements that will generate what we call into a script format. Script format or a coded format, a line of sets of code. Those are a scripted set of steps that you're going to execute. That's why we call it a script. And then they're going to go through the process. But can you take AI and look at that process and suggest a better path? Well, the answer is yes. But the key thing about AI, and this is very important from our operations capacity, is if you do AI, you have to own AI. So let's talk about that. Let's say you're an enterprise company, right? And the overhead of AI is basically driven on your data center resources. So in other words, when we're creating a GPU-like data cluster set, let's say we create a data system of 20 nodes. That's 20 GPU processing nodes that are dedicated to processing the requests, review the data, analyze the data mocks against the libraries, or the llamas, as they call them, and then come back with an answer. Now, the thing about AI, which is very important and is usually never really considered specifically on the cost construct, is the fact that the CPU constructs that are necessary to compute the values, may they be based on GPFS, I'm sorry, not GPFS, GPU style processing modes, which is known as open processing, or central processing, narrated processing, which basically means it's locked in code processing to get you to a place where you can get a result. And the answer is cost. To do it right and effectively, power, as in electrical power, to power that cluster environment will suddenly very quickly turn into your largest asset within your cluster environment. Some companies such as Microsoft, MSN, and a few others, Google included, have decided that they will go into better, more adaptive technologies to address this cost. But that's not something that's available to us in AWS or GCP or GSP and so on. Because when you look at Azure or Google or AWS, you're going to go into their what we call classical data structure constructs. These classical data structure constructs are data centers on the ground, out in the open, with multiple power sources, 100, 200,000 square foot floor space, so on and so on and so on and so on. Now, some companies have gone farther than that for themselves specifically, and they have done things such as underwater DCs or underwater data centers. These underwater data centers actually use the benefit of the cold environment to help offset some of the costs of running their AI cluster environments. Because just like the days of supercomputing, if you remember the days of Cray computers and all of the big supercomputer platforms out there, or basically HPC, high processing computing, those centers have the electrical cost, which produces the secondary cost, which is the heat dissipation cost. They got to get rid of the heat. And it's expensive. It's not cheap. So when you look at a query set and you have an adaptive capacity and you want to be able to use that, be careful what you jump into, because when you look at the cost model, you have to do it on your basic usage against the total sum of the value of your customer base. And that's a pretty hefty piece of hardware to make that happen. Now, like any boss who says, how do we want to use this tool, like I gave you an example earlier, the use of that tool is just that, is it applicable versus the cost? And when I look at that, I say, linguistically, yes. I think companies that work with communication, especially translating companies that work with currency variations, can use currency languages and things like that. All in all, you have the ability of being able to produce a result that is cost effective to profitability, not versus the functional cost of investment, which of course is not profit, that's an expense, right? So when we look at those variables, AI, you have to be very pragmatic about your approach. When you say, give me X, Y, and Z that shows me profitability, that will make me justify the cost of AI. Now, if somebody asks me that question, I think the bottom line is, I can give you a model of how to get AI off the ground. I ask you, what type of profitability do you think you can get by integrating AI to your environment? And that's very important. Scaling from one hemisphere to another hemisphere is valuable. You can use AI cross-intelligence to help revamp your websites to be more effective. Communication in different languages, and so on and so on. That's a really good variable. And the nice thing about that is it's processing AI. It is not interactive AI, which is very expensive. When you have AI interacting with our customers, okay, that's when it starts to hurt. But if you use AI to take your existing content and you want to present it in Portuguese, or you want to present it in a different language, or you want a whole EU language schema or something like that, okay, this is worthwhile. Now, at that point stage, I wouldn't build my own AI because I don't want to own that. I'd rather rent that from someone else and make them give me what I want. So my real investment is on the profitability side, not on maintaining AI. That's another step which I recommend. And this is important because I've been here for 35 years now, and I have seen this buzzwording forever. I hate buzzwords. I hate them. One of the worst ones is the word exactly. When somebody says that to me, it's like they've zoned out. You're just telling me what I want to hear. Just like the word enterprise, a good example. Just like the word cloud or multi-cloud or Hyper-V or I want to virtualize. These single buzzwords are what executives use, and they have to use it because, frankly, they just don't have the opportunities or the cycles to break it all down. Not yet. But on our side of the fence, that's not the case. We get into the detail, into the minutia itself. And at that point stage, then you can say AI can do X, Zulu, and Beta, but it can't do all 26 of the letters of functionality. Nothing can. Enterprise was not the answer for everything. Enterprise is what it is. It is an advanced deployment of a mid-size strategy of IT implementation. That's it. You just have a much bigger, better organized construct of what you used to do at mid-size, which mid-size business models are better than the small business models. And you have to understand that every verbiage, may it be USB or Bluetooth or enterprise or GPFS or GDPS or GDPR or just these buzzwords aren't the fix for everything. They're just there to service one thing mostly really well. It's when you bring them together in the right orchestration that it becomes very functional. So I wanted to talk to that because I wanted you guys to understand the scope and the nature of how broad AI can become, both in cost and complexity, versus profitability and what it takes to get there. And the expectation right now is 12 to 18 months to just platform ATI into an operational state on most common denominator types of industries. That's pretty right on par with most of the other things, such as IoT and so on and so on. Again, remember, you have to be pragmatic about the approach of AI and its true value, profitability versus non-profitability. And be careful of the last tiny detail. Don't defer your cost. Don't deploy AI and take it as an expense up front because you want to improve other functionalities that could be more profitable, that could have more profitability because you injected AI in the background. That is the wrong approach. AI actually needs to be kind of in the front end. If you really want to get reinforcement in your product lines, you need to have that reinforcement visible to the customer base so they can say, oh, well, you've got co-integration with AI intelligence. Okay, I got you. With that being said, that's my blurb today about how do you want to bring AI to the table. As most of the environments stand, they're starting to create AI in the other genres of technology, but the predominant ruler right now for AI is linguistics, languages. So there is absolutely a great value there, I believe. Oh, and for those out there at the end of this, and thank you for spending the last 11, 12 minutes listening to this, AI is an instruction set of algorithm call sets that counteract in regards to either performance, metrics, or a defined value. What does that mean? It means it's not going to take over the world. But if technology misuses AI technology, anything is possible. So, one very important last detail to suggest here. Not all technologies should use AI. There are technologies, specifically in the military industry standards, that should not use AI because of what that could potentially develop beyond AI. And that's a real risk because you have real concerns about what that could potentially become by itself. Is it a risk? And so on. So, yes, I believe that quantum computing, AI, adaptive clustering scaling, and many other technologies can provide the core functionalities to provide something that could potentially be very dangerous or very malignant by design, but it's only malignant because somebody thought it up. Remember that. Computer technology is really positive. It has a lot of functionality and so on. But when somebody perverts it into a weapon, which you should never do, or try to avoid as best as possible, so that you can keep that technology form low, it's important. What do I mean? Well, AI is just a service that uses a set of instructions, right? It's kind of like beans and bullets. In the military, we purposefully, in the military, do not deploy advanced weaponry systems. We may know how to build them, but we don't build them. We don't put them on our ships, and we don't put them on our planes, and we don't unless we absolutely have to. There's the key. So the theater of war is convoluted. It's difficult. To have war, it's hard. That's a good thing in my book. Make it difficult because you don't want to do it because you do terrible things when it happens. And I give credit to the leadership of the past 60 or 70 years of many countries, not just the United States. This includes Russia, by the way. They understand that if you escalate the nature of something to a greater, easier, and quicker way, the platitudinal result could be devastating. It's no different with IT technology. Remember that. And with this, I'm going to say, hey, I'm going to let you go. I hope this helped you. I hope this makes good sense. Everybody take care and God bless. Have a great week.